Unit 4, Module 3, Session 4, and this is actually Part 1 of liquid volume. I will say that this lesson is going to be a little tricky because normally I would have liquid in front of you and I'd be able to show you and stuff, but since I don't, we're going to do the best we can with this. I do have a video that I put in our group for you to watch after this as well. Okay, so real quick, I wanted to go over the answers to the homework from last night before I get started. So for number 1, it says use an open number line to model and solve each of these problems. Jacob woke up at 5:50 a.m. on race day. He got ready in 35 minutes and drove 15 minutes to the event. Will he make it to the race for the 6:45 start time? Explain your thinking. Yes, he will. And so 35 plus 15, so 50 minutes. So yes, he will make it. And that's how you could use the number line. Start at 5:50, jump 10 minutes to 6 o'clock, and then jump another 40 to 6:40, okay? And that is 35 minutes. So during her practice this month, Brianna ran one 10K in 1 hour, 2 minutes, and 18 seconds, and another in 58 minutes and 49 seconds. How much faster was her second 10K? So you can see that you've got 58 minutes and 49 seconds. To get to 59 minutes, that would be 11 seconds. And then to get to 60 would be another minute. And then to jump from 60 to 1 minute and 2 seconds would be 2 minutes. It's kind of hard to see that, sorry. And then another 18. So 102, 18. So altogether that's 11 plus 100 plus 200 plus 18. So that's 3:29. You can see that right there. Okay, so 3 minutes and 29 seconds faster. And then C, Trevor needs to be at the starting line by 8 o'clock in the morning. He needs 45 minutes to drive to the event and 20 minutes to eat breakfast. So 45 minutes to drive, 20 minutes to eat breakfast, and 15 minutes to shower and get dressed. What time should he set his alarm so that he is there at the race on time? 6:40 a.m. Work will vary though, so he needs 45 minutes plus 20 plus 15. So he needs 80 minutes, which is 1 hour and 20 minutes. So from 8 o'clock, if you jump back 1 hour, that's 7 o'clock, 20 more minutes, that's 6:40. So technically he should set his alarm for 6:40 in the morning. And then finally fill in the ratio table below. 1 minute is 60 seconds, 2 minutes is 120 seconds, 3 minutes is 180, 5 minutes is 300, 10 minutes is 600, 12 minutes is 720. And then for 2B, 1 minute is 60 seconds. 1 hour is 60 minutes. 3 hours is 180 minutes. 6 hours is 360 minutes. 7 hours is 420 minutes. 8 hours is 480 minutes. And 11 hours is 660 minutes. So those, my friends, are the answers to your homework from last night. All right, let's move on. So in this lesson, Liquid Volume Part 1, we will investigate liquid volume. We will learn to read measurements in milliliters and then solve problems in which we will convert milliliters to liters. We will be able to identify sizes of milliliters and liters. All right, so we've seen this chart quite a bit, and we've talked about length, and we've talked about time, and now we're going to talk about volume and capacity a little bit. All right, so with volume and capacity, words that you might come across with this would be ounce, cup, pint, quart, gallon, milliliter, and liter. Today, we're going to do some work with milliliters and liters, okay? All right, so going back to this chart here, the Run Far Distance Challenge 7 race series includes, remember, the 5K, the 10K, the 10 miler, the 18K, the half marathon, the 30K, and the marathon. So we're going to use the chart to help us. The organizers of the events have to set up water stations to keep the runners hydrated. How much water do you think that they will need for the race, or for each racer? So do you think a milliliter is enough for each runner? So I want you to think about whether or not you think a milliliter is enough for each runner. Yeah, a little bit of time to think. And then I'm gonna flip to the next slide in just a moment and show you something. And the video that you will watch that I've also attached will kind of explain this as well. Okay, so when you think of a milliliter versus a liter, a milliliter, do you think it would be enough for each runner? So a milliliter is actually, you know, a dropper that you would put medicine into or something like that? A milliliter is actually that little droplet of water that comes out. That, my friends, is a milliliter. So think of an oral syringe for medicine. So each drop that comes out of that syringe is 1 milliliter. So this amount is probably too small, right, for a runner? So yes, too small. Can you imagine running a big race and having just a droplet of water to quench your thirst? I don't think that that would be enough. So then if you think of the big Gatorade bottle, that's typically a liter, or I actually have, and you may have seen it before, I have a very big, tall Life water bottle that I bring to school every once in a great while. I like to drink Life water, and the really tall Life water is 1 liter. So if this is 1 milliliter, and this is 1 liter, that's a very big difference, all right? Okay, so now let's think about 250 milliliters versus a liter for a second. So I know that I don't have these things in front of you to actually show you, but you may have something like this at home. So I have measuring cups at home that look very similar to both of these. So 250 milliliters, I know that these look kind of like the same size, but this is how big a 250 milliliter cup is, okay? But what I want you to think about is this 250 milliliters would only fill up this liter container to here. Okay, so all of this would be full, but the rest of it would be empty. So that's how much larger a liter is than even 250 milliliters, okay? So when we were thinking back to that droplet of water and quenching your thirst when you're a runner, that milliliter is definitely not going to be enough, right? Okay, so there's no rule to determine how much water a runner should actually drink during a race. Runners have to learn to listen to their body, so for some runners, this 250 milliliters would be enough during a race. But for others, a liter of water is what is more necessary for them. So again, they kind of have to listen to their bodies. A milliliter is definitely not enough, but either 250 milliliters or 1 liter may be enough depending on the runner. So when we're talking about volume equals like the volume of a container, how much a container holds. So 1 liter is actually the same thing as 1,000 milliliters. So when we were thinking back to that dropper before, it would take 1,000 of these droplets to fill this liter measuring cup, okay? So that's crazy, right? Okay. So again, 1 liter equals 1,000 milliliters. So take a look at the purple charts right down here on the left. Here's the purple chart right here, okay? 1 liter equals 1,000 milliliters, okay? 2 liters equals 2,000 milliliters. And actually, Mrs. Sanders is I'm labeling this incorrectly right here, so it should actually be a lowercase m capital L, lowercase m capital L, so I'm sorry about that. Okay. All right, and then 3 liters equals 3,000 milliliters. So how many milliliters are there in 8 liters? So think about that for a minute. How many milliliters are there in 8 liters? So just like the previous lesson when we were using those charts and those tables to kind of figure it out, think about whether or not you need to fill in each row of the table or not, okay? So how many liters are in 8 liters? How many milliliters are in 8 liters? Sorry. I'm going to go ahead and draw a chart, and I want to use a different color because I feel like I've been using blue for a little while now. So let's change it up a little bit here. Let's use green. Green's a good color. All right, so I'm going to put liters on this side, and I'm going to put milliliters on this side. I know that 1 liter equals 1,000 milliliters. I know that 2 liters equals 2,000 milliliters. I know that 3 liters equals 3,000 milliliters. So I'm going to write this over here. If 1 liter equals 1,000 milliliters, and I simply want to figure out how many are in 8 liters, what if I just went like this? And I multiplied this times 8. So if I multiply that times 8, and I multiply that times 8, that must mean that if I have 8 liters, that's 8,000 milliliters. Okay, so how many milliliters are in 8 liters? 8,000 milliliters. Okay, now let's change our thinking a tiny bit. What if we were asked how many milliliters are in 6 liters? Ooh, changing up a little bit again. All right, how many milliliters are in 6 liters? I'll go ahead and draw our chart again. If I do liters on this side, and I do milliliters on this side, 1 liter equals 1,000 milliliters. 2 liters equals 2,000 milliliters. 3 liters equals 3,000 milliliters. Okay, so now if I want to figure out how many are in 6 liters, if I know that 1 equals 1,000, that's got to mean that if I've got 6 liters, it's 6,000 milliliters, okay? So let's talk about another way that we could look at this problem for a second. I could look at it this way and simply think, okay, liters milliliters, and I could put a question mark here, and I could think, okay, how many liters are there in 6,000 milliliters? If I know that 1 is 1,000, okay? So essentially what I'm doing is I'm kind of looking at it from an opposite way, and we've talked about this many times. Oop. Whoopsie, sorry. If I've got that question mark there and I've got my 6,000 here, I'm simply dividing by 6 to get 1,000 and dividing by 6 to get 1. Okay. So that's kind of how that's going there. So when I do that, I know that 6 divided by 6 is 1, and I know that 6,000 divided by 6 equals 1,000. So basically what I discovered, and these were kind of like the steps to get there, was that my answer was right here. And before, it was a question. So if you think about it as 6,000 equals how many liters, 6,000 milliliters equals 6 liters. Okay, so that's how I do that problem. All right, moving on to the next slide. All right, so we're looking at this one again. So 250 milliliters versus 1 liter, okay? So if I look at 250 milliliters and 1 liter measuring cups again, how many times do you think that we could have or would have to fill up the 250 milliliter container to equal the larger 1 liter container? So again, if I'm looking at these two containers that we were just looking at a few slides ago, how many times do you think that we would have to fill up the 250 milliliter container to equal the larger 1 liter container? So I know that 1 liter equals 1,000 milliliters, 2 liters equals 2,000 milliliters, and 3 liters equals 3,000 milliliters, okay? So knowing that information should help me with this next one. Okay, so how many times would we have to fill up the 250 milliliter container to equal the larger 1 liter container? All right, let's use blue. All right, we're gonna use blue this time. I'm gonna make another chart. Okay, so number of 250 milliliter containers versus the number, whoops, I'm so sorry, versus the number of milliliters. So if I've got one container, okay, that's 250 milliliters. If I've got 2 containers, right, that's 500 milliliters. Now, notice that I'm kind of going up by 250, okay? But what if I multiplied by 2 again, and I had 4, and if I multiply that by 2 again, ooh, there's my 1,000. So, how many containers does it take, or how many times would I have to fill up the 250 milliliter container to equal the larger one? I would have to fill it up 4 times. Now, the first time I did this problem, I automatically thought of money. So when I looked at this chart, I thought of money to help me figure it out, because I know that when I've got $1, right? So let's just say this is $1. You know, this doesn't look like $1. Let's pretend that there's a face in the center here for a second. We'll just put somebody's face in the center. Okay. Okay, so we've got $1, right? And I know that I need 4 quarters to equal that $1, right? There's 4 quarters and $1. Now, when you look at this really carefully, there's that 25 right there. All we were doing was adding another 0, if you notice. 25 and 100, or 250 and 1,000. So if there's 4 quarters and $1, then it would essentially take 250 plus 250 plus 250 plus 250 4 times to equal that 1,000 milliliters, or that 1 liter, okay? So how many times? It would take 4 times. So here's a little way you can connect money with measuring as well. So we know that fractions are linked with decimals, and even when we're talking about measurement, that also links with money and decimals as well. So it all kind of comes around. All right, so the last thing that I'm going to have you do before I tell you your homework, so in the link for where this video is, you probably saw that there's a link to another video. I do want you to watch this video about decomposing liters and milliliters after this lesson, okay? Because it just kind of helps out, and it's basically what I would have done if I were in the classroom with you, but since I'm not there, I figured I'd show you this video. I thought about videotaping it myself, but I was unable to find all of the things that I needed. So because of that, I want you to watch this video instead, okay? And then for your homework tonight, you're going to finish student book page 153 for homework. Now, I'm going to do the top part with you, and the reason why is because we don't have stations that we would have had in the classroom had we been in there. So I would have put together a bunch of stations for you, and it would have been so much fun if we could just be together, and I'm so sad that we can't. But we're gonna just make the best of it and do the best we can here like this, all right? So I'm just gonna fill in this first part for you, this section, and then you're gonna fill in the rest for homework tonight, okay? So you're gonna do numbers 1, 2, and 3. All right, so it says to visit each station and examine the measuring cup filled with water. This would have been such a blast. Fill the chart below with the volume of water each runner drank, and then answer the questions that follow. All right, well, I'm going to fill this in for you because you can't see those containers of water, right? So the first one is going to be runner A, 125 milliliters. So go ahead and write these down in your paper. Runner B was 175 milliliters. Runner C was 500 milliliters. Hold on just a second. Runner D was 250 milliliters. Runner E is 75 milliliters. Runner F was 650 milliliters. Runner G was 525 milliliters. Runner H was 450 milliliters. Runner I was 400 milliliters. And runner J was 750 milliliters. So if you could fill those out in your chart. So remember what we talked about earlier, a runner, what they need as far as running would vary based on the runner. So one runner might need 250 milliliters and one runner might need a whole liter, which is 1,000 milliliters. So it all just depends on the runner, right? So your homework tonight is to answer questions 1, 2, and 3 based off of the information in this top part, okay? So here's the information for you in the top part. I would like you to fill in the rest for homework tonight and submit it into Seesaw. All right, boys and girls, have a great day, and we'll see you tomorrow.